In our first mold extraction, we went through a simple mold layout without too much nuance to get familiar with the tools involved. You can go back and watch the first part using the card here, but now let's try a mold that's a little bit trickier so we can get a feel for what considerations we might need to make when applying these functions in a more complex situation. This mold here has our ejection system. It has a core and cavity side of the mold. The runner system is relatively straightforward. It's just a sprue going straight down and dirigating onto the part surface. And so we need to extract all of the components that are not already built into the mold. First of all, let's go ahead and find the part geometry. We can actually do this pretty easily by just hiding the core and cavity sides of the mold. I can highlight both of these, right click, hide selected. In some mold systems, there might be a core and cavity insert blocks that you might need to hide as well. But in this case, you can see the geometry is quite simple. And we can go ahead and attribute that as a part so that we can start organizing this information. All right, I can go over to the model tree and I can hide the part. All right, we can see all these different components that might or might not be necessary. Generally speaking, the ejection system is not necessary. So I will usually highlight all of that information and I'm not going to delete it. I still want that information there in the case that it is necessary. But I am going to right click, edit attribute, and I'm going to throw that into a user defined group so that I can hide and show that system a little bit easier. And I can throw other things into that user defined group if I want to as well. I'll just call this ejection. You can change the color using the little color block over here on the right. Let's do a magenta color. Now, interestingly enough, we can see that there's some objects that have not reset their color. And the reason for that is because they came in with some color from the CAD system. You can see those colors already associated over here. And if we highlight everything, right click, reset to default color, you'll see that they'll all go to pink. I'll add a none, right click, edit attribute, and I'll add a user defined group here, add, right click, edit attribute, and I'll add a user defined group here, add. Right, we can either assign this as the same color or a different one. The colors that I usually recommend are magenta, green, and maybe like this darker blue, as those don't really have any overlap with the other attributions in Moldex3D. So we can see that that is also a user-defined group that exists now. I can also remove all of the default coloring that was there. All right, so now we have a bunch of information. Might be able to just hide this guy. Maybe I could add that to some other group. All right, but all this information I think I'm going to need, and we'll see why that might be in just a moment. All right, but everything that is not in one of these user-defined groups, I'm going to bring back. You can see that there's a lot of objects here. All right, first thing I'm going to extract is my runner, which, like I said, in this case is quite simple. So we have just this sprue going down to the surface of the part. Just like in the last mold extraction video, even for a runner system, you can still use the same tools. So if I go over to the tool tab, create more, and extract channel wizard, I had this pre-selected. So you can see the extractable objects are kind of highlighted in orange here. There's some feature lines that are highlighted in blue still that are not extractable. So if I highlight this guy, you can see that it selects kind of like in an orange color, and it changes the feature lines to red, indicating that we have selected that in the entirety of that channel, not just the surface that we clicked on. I'll press the green check mark. All right, and that extracts that geometry. Now it has actually taken out the interface with the nozzle or the sprue bushing. So it has extracted a little bit more than we want, but that's okay. We will deal with that in just a moment here. So edit attribute. I'll change this to cold runner for now, just to organize everything. And we can turn that off. This guy we can add to a user-defined group. I'll call this a runner insert. All right, and I'll have it vaguely similar in color to the cold runner attribution, so I'll put it as that blue color. And just like before, we can reset the default color. All right, we can get rid of that. All right, so now we have our runner extracted. Now we need to go through and do our cooling channels. All right. So to figure out where my cooling channel lines are actually routing through my mold, I can go in and make everything transparent just to be able to see below the surface a little bit easier. I don't like to just hit the transparency button because that's going to turn everything transparent. Actually, some of these bushings, it'll help to not have and these hoses on the other side, it'll help to have them not transparent, just so I can see a little bit easier where the interface with those components is. All right, so I'm going to actually just highlight the core and cavity side, and then I'll hit the transparency button here. That'll allow me to see the lines going through the mold just a little bit easier. All right, so it looks like we have 1, 2, 3, 4, 5, 6 lines going across the mold, and it looks like they loop through external hoses or some sort of fitting here um, to have an inlet here and an outlet here. Actually, it does say it on the mold, so we have an in, out, and so on and so forth. You can kind of see where those are. And it looks like we have a channel going around the part, just like in the first mold extraction we did. Looks like this one has one going around on the top side of the part, and then we also have a bunch of straight lines going on the bottom side of the part. All right, so let's go through and extract all of these channels. Now, we do want to represent the contact with the outside of the mold as accurately as possible. All right, so if I highlight these channels here, if I were to extract this channel, it would bring it all the way out to the edge of the mold, which we don't want. We want just the inner channel. All right, so we're going to go through and do the extract channel wizard. Now we're going to do the extract channel wizard to try and represent the contact with the mold as best as possible. And when I say that, I mean, I want the line to go kind of up to this boundary right here. You can kind of see that. And then I want it to go into the bushing here. So I'm going to extract the channel from this object, and then I'm going to extract the channel from the mold itself. All right, now something cool that you can do is you can do a lot of actions all at once here. All right, so I'm going to use a left to right box select because we've gotten rid of a lot of the redundant objects in our mold. I can box select all of these components. You can add that all to a user-defined group, but also you can just have them as separate objects and then just use a left to right box select. Remember, that's an exclusionary box select, so only the objects within that box would be selected using that left to right. All right, so I'm going to do that, and then I'm going to go more, extract channel wizard. All right, we can see that all of those channels, I'm going to hold the shift button. Now it looks like when I select the inside of this surface, it only gets about half the bushing, which I want the full thing. So I'm going to extend that a little bit further. Again, I'm using the shift button to continue my selection here. And you could do this in multiple steps if you wanted to. I'm just doing it more for efficiency. But if you wanted to do these one by one, there's nothing wrong with doing that. All right, so I've got all those, check mark. Excellent. So now it's created. And you can see that it automatically combines, even though I had to select those separately, you can see that it automatically combines those into a singular geometry. All right, cool. And something important to note here is that these new objects that I've created will always be the highest polysurface number down in the non-attributed section. So I can go down to the bottom here and we can see that 157 through 170. Oops. These are probably the ones that I just created. And in order to separate them from the rest of the non-attributed objects, I can either add them to a user-defined group, or you know what, since they're going to be cooling channels, I can just attribute them as a cooling channel, and then I can close out of there. That'll just make my life a little bit easier. All right, I'm going to do that for the rest of these components. Again, you could do these all at once if you wanted to. Now this one here, I'm going to show how to handle the hoses in just a moment here, but the connectors I'm going to have extracted separately. Now on this side, the hoses themselves might get in the way, so I might hide those for the time being. Yeah, we're going to turn those off for the time being. I'm going to add these to a user-defined group just to make them easier to group and hide and show. So I'll just call these hoses. All right, and we'll give them like a gray color. Again, these colors can be whatever you want to as long as you can tell which one is which. Usually the name is more important than the colors. So now with those gone, I can use the left to right box select. If I use the right to left box select, it's going to select the mold, which I don't want. So I'm going to rotate around a little bit to grab these two. All right, we're going to use that same function, extract channel wizard. All right, so with all those selected, check mark. All right, and all those objects get created. Now, something else interesting to note, when we extract these channels, they will be automatically selected. So I can just, instead of having to scroll all the way to the bottom and then select all these, I can actually just go in and directly attribute these because it knows that we've created a new geometry and we probably want to assign that geometry in some way or another. All right, so I'm going to go through and assign these as a cooling channel, just like the other ones. Excellent. All right, now I can turn off all these bushings. All right, so we see that we have the lead in for the cooling channels. Now we need to continue with the rest of the extraction here. We're going to go through and extract this perimeter cooling channel first, and then we'll do these straight lines going across, and then we'll finish things off by extracting those hoses. All right, so I'm going to get rid of my cooling channel attribution for the time being so that I can see that opening a little bit easier. Now, something interesting to note, when you attribute a bunch of objects, it'll create loops up in the cooling channel section. And these loops are meant to represent where there is a coincident surface between cooling channels. It'll automatically recognize that connection and it will loop those together. So when we extract this channel going around, because this cooling channel that we initially extracted is going to be in contact with the next one, and then that one is in contact with the outlet, those three will be looped together automatically. So the mesher knows that there's an interaction there. But when you do extract these components, each one of these objects are going to be an individual loop, which can make this list quite long. What you can do is go up to the top of the list to the parent, which in this case is the polysurface slash mesh. I can right click and collapse sublayer. All right, and you can also even just hit this arrow here, and that will allow you to kind of collapse everything. So it just makes things a little bit more manageable because this list gets very long very quickly depending on the number of objects that you have, and this scales very, very fast with the number of objects in your mold. That's why we try to get rid of these objects. We try to organize those as quickly as possible so that we can make the attribution as efficient as we can. All right, so once again, I'm going to get rid of the cooling channels for now so that I can see that inner channel a little bit easier. All right, I'm going to use that more and extract channel wizard. I'll select the upper side of the mold here. All right, and we're going to check mark, and then we're just going to click in this channel. Very nicely, it looks like it's just extracted the smaller diameter cooling channel, so it didn't come all the way out to the outside like I was thinking it might, which is great. Okay, so now with this cooling channel selected, check mark, and it creates that solid geometry, which is awesome. That's what it should be doing. All right, because it's selected, I will just use this opportunity to go ahead and attribute that cooling channel. All right, and so now we can see that loop 21, it has looped all three of these objects together because it recognizes that these three objects are coincident, which is great. It allows us to, we don't have to Boolean all these objects together. The mesher automatically knows that these objects are associated. So when we go to mesh, the mesh will be connected between those automatically. All right, so I'm going to go ahead and turn off the cooling channel attribution again. And we're going to go through and do all of these straight lines across this upper half of the mold. More, extract channel wizard. All right, and I'm just going to select the inside channel. I actually don't need the outside area. I don't need this either because I have that with my bushings that I extracted earlier. Check mark. All right, right click attribute, and we'll put those as cooling channels. All right, so if I scroll up in my model tree, I should be able to see that those loops are automatically being combined, just like the previous one. And that's an indication that there is a coincident surface there and that we've done the extraction correctly. All right, so I do have to go through and do the extraction on the bottom side. Let's go ahead and do that real quick. More, extract channel wizard, check mark, and we will right click, attribute these once again as cooling channels. All right, we can see that our list actually got a lot shorter before. It was around 30 something loops, and now we're down to 15, which is what we want to see. And you can actually go in and count how many loops there should be, especially if it's labeled on the mold like this. There's 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 cooling channels in total. Right now we have 15, and the reason for that is because we haven't yet looped this channel here with this channel here using the hoses on the outside of the mold. Now the hose itself does look like it has some sort of wall thickness to it. All right, so we're going to extract the inside of the hoses here. All right, so I'm going to select those. Now, when I go to do this, the inside of this hose can be kind of difficult to select through the other surfaces. Even though I have it transparent, it's going to be kind of difficult to select that. So there's a nice function or a nice tool that you can use, and that's right click, show selection only. And so that will hide everything except for what you have selected. All right, I'm going to go through and do the extract channel wizard. All right, and we can just go and get all of these guys extracted. Check mark, right click, attribute, and we'll assign these as a cooling channel. Now, interestingly enough, these do go outside of the mold. So we could call them hoses. That would be the attribution that we would use for an object that goes outside of the mold. But honestly, I usually like to just consider them as regular channels. The heat transfer that happens out of a hose is pretty negligible with respect to the amount of heat transfer in the system, the actual system that we're trying to consider. And it increases the complexity of the meshing unnecessarily because those hoses need to be in direct contact with the mold surface. So then I need to make sure that the mold surface goes up directly to the surface of the hose, which can be a little bit tricky. So I usually like to just consider these as regular channels and just put everything inside of the mold. That's kind of the best practice and makes life a little bit easier for you. All right, so it looks like we've created, it looks like 7 new objects, but those aren't looped with the other channels here, which is something that we definitely need to figure out why that might be the case. All right, so if I highlight the hose, we can actually see that there is an overlap between the hose and this connector that we extracted from the bushings. All right, so actually what I'm going to do is I'm going to Boolean these together because then there's a coincident service here, and then that coincident service will match here. All right, so that's ultimately what I want is for everything to just be kind of coincident with one another. If we have an object that's going through another object, this loop wizard is not going to automatically recognize that interaction. All right, so I'm going to go through and do a union for these 3 objects. That's under the tool tab. And then over in the edit section, there is a bunch of Boolean functions here. I'm going to do a union in this case. All right, I'm going to select actually all 3 of these surfaces, check mark, and we can see that it automatically just kind of puts those together. And now because that interaction is more identifiable, now we can see that loop 5 has 5 objects, which is 1, 2, 3, 4, 5, going from the inlet all the way to the outlet. All right, I'm going to do that for each of these loops. And you could union all of these. If you wanted them to just be one object, you could union all of these, but it's not necessary. As a shortcut, when you're doing a function repeatedly, you can use the space button on your keyboard, and that will repeat the last command that you did. So I just select all three of these. And because I already did a Boolean, I can just hit the space bar and prevents me from having to go up and hit union every time. All right, so now I should have just 8 loops. Let's see if that's the case. Yep, it looks like I just have 8 loops, and that's a good confirmation that I've done everything properly. All right, so I turn on my parts, I turn on my runner, and we have our cooling channels here. Now, before I go and create a mold base, there's a couple of things that I need to do, and that is assign the boundary conditions. All right, we have a few boundary conditions that we need. We need the melt inlet, we need the coolant inlets and outlets in order to properly create a mold base. It'll need that sort of recognition as to what surface is meant to be what. All right, so first thing I'm going to do is handle the cold runner. Now, I mentioned earlier that there's kind of a, the interface with the nozzle was also extracted, which isn't always the case, but I guess maybe the coincident angle here was a little bit lower than 90 degrees, so it might have automatically associated that. But let's go ahead and remove these unnecessary surfaces. We can do that under the Edit Tools, More, Delete Face, and I can just select my object and then find those surfaces to delete them. All right, now there's two ways that I can handle this object. Obviously now I have an open face on the top side, which is a problem. That is something that I would need to fix. I can either do that through the surface mesh if I keep this as a geometry, but actually I am going to extract this as a center line just to make my life a little bit easier when it comes to meshing. All right, so to do that, I'm going to highlight this object and use central line. All right, I select my object, okay, and it extracts the center line for me. If I attribute that directly now as a cold runner, it will identify automatically the inlet diameter and the outlet diameter since it sees the geometry that this was extracted from. This is a nice little nuance. Rather than having to measure the diameters, this just kind of automatically attributes it. All right, I definitely want to make sure that I don't have two objects in the same location, so I'm going to delete my original polysurface. And now we have our line that represents our cold runner. I'm going to make sure that I put the melt inlet on the top here. So I'm going to go to model, and then I can use the automatic melt entrance function, or I can use specify point to manually place that inlet. But the melt entrance function will be more than sufficient for this simple runner system. Now I can do the same thing for the cooling channels. If I highlight my cooling channels, I can go to tool and central line. All right, and it will extract all of these straight lines on my geometry. It will not extract the hose object here. I'll need to do that in a separate step, which we'll do in just a moment. But with all these new lines created, I'm going to select all those from my model tree. That's usually the easiest way to go about it. Another way is if I go up to here, I can click on the drop down and select all curve objects. Now you just have to be a little bit careful with that just because the runner is also a curve object. So if you still have that showing, then it might select that and kind of mess with your attribution. But if I right click, edit attribute, I can then go through, assign these as a cooling channel. And just like the runner, it will automatically assign these lines with the correct diameters based on the geometry they were extracted from. So now we have these hoses that we need to extract the cooling channels from. Interestingly enough, it's not that complicated necessarily. It's just that these non-straight channels are identified slightly different than these straight channels. All right, so these straight channels are considered as channels, whereas these curved channels are considered as tubes. All right, and they do have to be done in two separate steps, which is a little bit annoying, but it is just the way that the function identifies these objects. All right, so I'm going to go through and do this central line one more time, selecting these hose objects, central line, All right, so we can see that it selects them as tubular polysurfaces. Okay. And then I can just go in and directly attribute those as a cooling channel. All right, so we can see that it goes through and assigns the correct diameter, but there is something that we need to consider, and that is the cooling channel overlap. All right, now when we originally extracted this, it found all of the straight areas of the cooling channel and it extracted those. But this object here, if I go back to the poly surface, this object you can see goes all the way from the curved section through the straight section. The straight section was automatically extracted when we did the channel extraction, the first one. But now that we've done the tubular extraction, it also extracted these areas as well. So there are two lines overlapped for all of these. I'm going to turn off all my poly surface since I have extracted all of that information. If I select any one of these sections, you can see that there's two of them. Now, there's actually a really easy way that we can handle that, and that is through the remove overlap function. Something that was very recently introduced that really helps to clean up our cooling channels and make the meshing as smooth as possible. So what I can do is I can just select all of these lines. I did a left to right box select to select all of those lines, excluding the ones that are going across my mold. Anywhere that I would expect a potential overlap, and this remove overlap function will just go through and remove any sort of overlapping curves that it identifies. So you can see that there's two curves overlapped. All right, I'm going to select all those lines, remove overlap within a certain tolerance. You can just use the default tolerance. All right, and so now you can actually see that there's only one line for each of these objects. So really, really convenient function that helps us to really shore up everything and make everything as easy as possible to mesh. All right, so now that I have all of my loops, I'm actually going to get rid of my poly surface so that I don't have two objects overlapping. So I'm going to, you can either unattribute these or you can delete them either way. We still have the geometry in our non-attributed section that would allow us to extract those if we needed to again. But I am going to delete them. And after I do so, I'm going to go back to the model tab where I'm going to create my mold base. Now, I mentioned a moment ago that you need the inlets and outlets. Really, what we need is a clean representation of where the inlets and outlets should be. So we just need to make sure that all of these open faces are as easy to recognize as possible. And most importantly, all of these open faces need to be on the same plane. All right. So if I go to the front side, for example, I shouldn't see that any of these channels are mismatched with one another. They should all be on the same plane. Now, what this mold-based function does is it takes the outermost open surface. So it might actually identify these open surfaces as inlets and outlets because we haven't assigned anything yet. It has to kind of make some assumptions. But this one here, the outermost surface is here, so it won't truncate the mold base on these surfaces. It'll find the outermost surface. All right, so I'm going to use the mold base function, and we can see that that's exactly what it did. All right, so it found these two inlet and outlet, and then it found over here, and it found that this surface should be interacting with those inlets and outlets as well. All right, but it did create an interface here. So I want to take this opportunity to show how to extend one side of the mold base, because if I just increase, let's say, my W dimension, all right, so if I increase my W dimension, it does so by default from the midplane of the mold geometry. All right, so if I increase this to 500, now we can see that, yes, it's pulled the mold base off of these cooling channels, but it's also done so off of the inlets and outlets, which is going to be a problem. All right, so instead of using an absolute value for my length and width, something that gets overlooked is the ability to set a relative value. All right, so what I can do is I can set a relative value for each of these dimensions. Now we can see that I have L1, L2, W1, W2, and by default, that's going to be from the part center. I can change this to be a custom. And if I want to keep my mold base on my inlets and outlets, then I can use those as my reference. We can see that W1 is 0 and W2 is the original width. I can just increase that W2 now. So let's say 500. and it will retain the mold-based interaction with the inlet and outlet on this side while pulling it off of the open ends on this side. All right, I press the green check mark. All right, so now we need to go through and assign the inlets and outlets. Now, the nice thing is, because these are identified as a loop, the inlets and outlets will be assigned automatically. All right, so I'm going to go up to the cooling system. I'll hit inlet outlet. All right, we can see that it assigns all of those arrows automatically. But let's see if those are actually correct based on our mold geometry. Remember, we had callouts for the inlets and outlets. We want to make sure that those are as accurate as possible. This function isn't smart enough to recognize any words that are printed on the mold itself. So we will have to do this part manually. All right, I'm going to find my mold objects here. All right, so we see that in, out, that's correct. In, out, looks like these ones on the top side are correct, but the ones on the bottom side, it looks like are incorrect. And the flow direction is actually important sometimes based on the application and the proximity of the cooling channels to the part surface. If I want to invert the direction of flow, then what I'll do is I'll hit reverse inlet outlet. And all I have to do here is either click on the inlet or outlet of the cooling channel that I want to reverse, and it will reverse both of them automatically because of this checkbox here that says reverse all inlets and outlets, as long as they're associated in a loop. All right, now we can see that all of our inlets and outlets are appropriately assigned. I can get rid of my two mold halves. And at this point, we're ready to mesh. Now, one last thing that I'd like to note is the fact that the mold is a little bit taller than necessary. You can shore this up by just going back into the mold base function and getting those dimensions correct or as close as possible, but I'm just going to leave them as they are now. All right, so I'm going to go over to the mesh tab, and we're going to start with the node seating. Now, interestingly enough, for this mold, everything is a lines except for the part itself, and I guess the mold, but the mold doesn't get any sort of meshing parameterization. All right, so I'm going to go ahead and do a node seating for the part. Use the Goldilocks method to assign the node seating here. Let's see what it gives us as a default. Apply. All right, actually the default node seating seems pretty close. Maybe this is like 4 to 5 nodes width of space. If you want a clearer breakdown for the Goldilocks method for node seating, we do have a video that you can see here that will go through that procedure for you. All right, but I'm going to just reduce the node seating, let's say by half. That's a little bit too small, so maybe we'll go up to 4. Yeah, 4 looks pretty good for this part. Check mark, check mark. All right, and let's make sure that all of our parameters are correct. So I'm going to go parameter. We want a 5-layer BLM, and then we want a 3 offset ratio. That's what we use for the part. Now the runner and the cooling channels are both curve objects, so they're going to use the curve meshing. So don't get tripped up by the attribute up here showing that there's runner and cooling channel. Those objects are not in our mold currently. Those types of objects are not in our mold currently for those attributions. We only have curves for our cooling channel and runner, right? And we're just going to use the default for both of those curve objects meshing styles. We use the runner as 4 inner and 5 outer layer, and then the cooling channels as 3 outer, 2 inner layer. All right, so now we're going to go to generate, and we'll generate the mesh. As a side note, you can stop the mesher at any point by putting a little tack here, just to create a save point for yourself, maybe. Or just to check out, like, for example, if I want to see the solid mesh of the melt system. All right, looks like we have an error here for fail to create the solid mesh of the gate region. So let's go ahead and check that out real quick. All right, so it is looking at the interface between the part and the runner. All right, let's hide the gate real quick. Oh, okay. So we can see that there is a kind of like a dimple on the part surface, which is definitely common. This is usually where the identification for the gate location is going to be. In the simulation, it really doesn't do a whole lot because there's melt that's just going to be going down through the runner. So actually from the surface mesh level, I'm just going to get rid of these mesh elements. I'm going to go to fix mesh. And you can get a more detailed breakdown of all of these tools over in the video here, but we're going to go and delete all of these surface meshes, I should say, not surfaces. The surfaces themselves are still there. We're just deleting it from the mesh level. So I deleted those three. I just highlighted, pressed the delete button, and then I can just fill the hole in. All right, that effectively gets rid of that feature. And hopefully now if I go and hit generate, it will create the solid mesh for me. All right, pretty easily handles that interaction. All right, and it stops the mesh because I placed that tack there. All right, so we create the 5-layer BLM for the part, and then that line defined runner. I'm going to hit the save button, and then we'll generate the rest of everything else. All right, now that the mesh is done, we can hit final check. All right, with the mesh completed, we are good to continue on with setting up the rest of our analysis. Thank you for watching this Moldex3D mold extraction tutorial. If you'd like to see any other topics covered in the future, you can leave a comment below. Make sure to like the video on your way out, and you can subscribe to the Moldex3D North America YouTube channel to get notified when new videos are posted. Thank you, and we'll see you in the next one.